Unity just launched its official Unity CLI only weeks after Unreal Engine 5.8 shipped its official experimental MCP server. Both promise the same outcome: let an external AI agent operate a real game engine, not merely write code beside it. But they solve the problem from opposite directions. Unity starts at the terminal and reaches into the editor and player. Unreal starts inside the editor and exposes typed engine tools through MCP. So which workflow is actually better for agentic game development? The launch window is already moving. A first Unity CLI reaction passed roughly 6,500 views in 5 hours. An Unreal 5.8 MCP quick start reached about 77,000 views in a month. A limitations and improvements video reached about 87,000, while a hands-on Unreal gameplay test passed 120,000. The strongest demand is not another setup guide. It is a clear verdict built from real capabilities, real limits, and a workflow developers can choose today. Unity's new design has 3 layers. The standalone CLI manages editors, modules, projects, and authentication without Unity Hub. It returns structured JSON or TSV, predictable exit codes, and supports unattended installs and service account authentication for continuous integration. The experimental com.unity.pipeline package then connects the CLI to a running editor or development player. Finally, the eval command uses Roslyn to execute C# in the live process, avoiding a project recompile and domain reload for rapid inspection and repair. Unreal Engine 5.8 takes the protocol-native route. The experimental Unreal MCP plugin embeds an MCP server inside the editor and listens on local HTTP-compatible clients such as Claude Code, Cursor, Gemini, Visual Studio Code. And codecs can connect through generated configuration files. The All Toolsets plugin exposes actor, scene, material, slate, lighting, and automation test operations. Tool search keeps the initial schema small, and teams can add new tools through Python or C++ toolset definitions. For machine setup and continuous integration, Unity wins. One binary can install an editor, add modules, authenticate, open a project, and emit parsable results. For editor-native discoverability, Unreal wins. The agent can list tool sets, inspect typed schemas, and call focused engine operations without inventing C++ or Python for every task. For open-ended power, Unity's live C# eval is exceptionally broad. Unreal counters with hundreds of tool calls and first-class Python or C++ extension. This is terminal breadth versus editor-native structure. The real benchmark is not object creation. It is closed-loop proof. Unity can query a running project, change state through a registered command or eval, enter play mode, and operate development players with the runtime flag. Unreal can inspect actors, configure lighting and materials, drive editor operations, inspect Slate, and run automation tests on the game thread. Both become valuable only when the agent reads the return state, captures visual or test evidence, and retries a narrow step. A beautiful viewport without a passing interaction is still only a demo. Both products publish important warnings. Unity labels the CLI and pipeline package experimental, and the current installer uses a beta channel. Unreal says many MCP features are incomplete or missing, and its API and data formats can change. Unreal tool calls execute serially on the game thread, so clients should not overlap them. The server is loopback only by default and has no authentication layer. Cooked builds can host the server, but editor tool sets are not automatically discovered there and must be registered directly. Unity's eval reaches the engine and project API through live C#, and Unity says that power is gated behind the account authentication token. Custom static methods become commands with the CLI command attribute. Unreal's default local server has no authentication, so Epic explicitly says it is not safe to expose beyond the machine. Its typed toolset model gives a smaller action surface, but direct tool registration and custom Python or C++ still require the same discipline: least privilege, local binding, explicit logs, and reproducible tests. My verdict is not that CLI beats MCP. Unity even includes an MCP mode, and every Unity command can map naturally to an agent tool. Choose Unity CLI when your bottleneck is provisioning, continuous integration, repeatable terminal automation, or live C# access across editor and development builds. Choose Unreal 5.8 MCP when your bottleneck is deep editor control through discoverable typed tools, especially actors, assets, materials, Slate, and automation. The next winning workflow will combine a small tool surface with ruthless verification. The protocol is plumbing. The feedback loop is the product.